As you know, my drone fell on water due to overloading of batteries. Due to water damage, one of my ESC got fried. So I thought, is it possible to repurpose the cheap drone flight controller? Even on a cheap drone, you could get a flight controller, a receiver, and a transmitter for BLDC motor, camera, optical sensor, and sometimes GPS. And nowadays, drones are quite cheap and affordable. Even though they are cheap, usually they are 5-inch or lower. So I thought, is it possible to make larger 10-inch drone from this small 5-inch drone flight controller? For that, you will be needing a drone frame, 4 BLDC motor, and 4 ESC. Be mindful of the kV rating in BLDC motor. Higher kV usually gives higher speed but lower torque. So, for larger drones, you usually have to find a BLDC motor with lower kV. First of all, you have to remove the top cover of the drone, then remove the propellers and motors. You can use them later on another project. So you remove them, remove the PCB, mainly the fly controller. So for me, my driver was broken, nothing else was broken. So I think we could make a larger drone. So you see there is three pin three pin here which goes to the BLDC motor, 3 pin right there. Then you see the other 3 pin. One is ground, another is power supply, say 4 voltage from the battery, and another one is the PWM signal from the flight controller. So you have to find the PWM signal on each of the BLDC drivers. To do that, you have to do is take your multimeter, then get the probe, connect each of them until you find 4.2 voltage, which you get from the battery. When you get the 4.2 voltage, you will know that which one is the ground, which one is the V in. Then you will know which is the last one is the PWM signal. You have to connect it like this, then connect the battery here. So on multimeter you will probably get a positive value. This is a negative value. If there is a negative shown, then you are connecting it in opposite direction. So you're connecting it like this is the ground and this is the positive. So I just roughly made the battery. So this is the positive. If you don't know, this is the positive and this is the negative. There we have it. So you get 3.52 connected. And on the drone, we will start to get the blink. So it's now ready. Slide down. You have to find the pins. So first one there. So there you go, 3.49. So the middle one is the ground, then the top one is the signal, the control signal, then the bottom one is the voltage. Yeah. So you have to find for the individual remaining 3. So I soldered the wires. You can look closely. The first one was the power, the V in, then the ground, then the PWM signal from the flight controller. So you can also see here the middle one is, I think, always going to be the ground one. I had this type of connector lying around, so I used it. If you don't have it, it's fine. It's going to be convenient if you are thinking about changing the motor drivers. So you can see that the output voltage from the PWM signal is going to be 1 voltage somewhere. And then, so it's like 1.9. All of them have 1.9. So in the next step you have to get your motor and motor driver. So I'm going with a cheap motor driver in motors, BLDC. So it's a 1000 kV, so it's not going to be used for super fast, just going to be hover and take some videos. Yeah, if you are going for super fast, you won't get super fast, but if you're going for fast drones, then you should go with higher kV. If you know about this, that you have to calibrate the ESCs manually, because our flight controller is not traditional one, so you have to calibrate the ESC manually. To do that, you can use a ESP32 module. You can do this. You can get a ESP32. Then I will give a code to manually calibrate all the ESCs. I'm recommending you guys to use hot glue. Then going to the frame, I'm using this generic frame. You also get this kind of PCB. It's very convenient for wiring. Now to calibrate the ESC, we have to read the PWM signal from this flight controller. Usually 1000 to 2000 is the value. Is 1000 the minimum, 2000 the maximum. Usually that's the PWM, but you have to check whether it's correct. So you have to upload a code to the ESP32. Link in description. There will be a code for ESP. Connect the ESP, then type ESP32 dev module. Okay, verify and upload. You have to see that this is the Wi-Fi password and name. This is the password. This is going to be the name. So you can edit it if you want to change it. Completing, you have to click the serial monitor, then click restart on the ESP. Then you will get a IP address. Copy that, go to your Wi-Fi, connect to the ESP Wi-Fi. After connecting to ESP Wi-Fi, then go to your browser, paste then you will see this interface. Then you have to connect GPIO 25 to the flight controller. To do that, you have to use jumper cables. The red one is the main, is the positive, and the black one is the ground. You have to connect it. After you connected that, you have to give power to the flight controller. Then look at the peaks. Then turn on the flight controller. Now it's on. So the base is 1 1.8. This is for turning on. You have to rotate it. Sometimes the flight controller will not work, so the signal is now fixed. Yeah, go with the then go to your controller, turn it on. Now it's connected. Now if you do lift, this is going to be the rotate, the first phase of the drone. So it's like 129. So 129 is the base. So you know that 129 is the base. So it's now dropped to 1000. So 129 is the base, then full throttle. So almost 2000 is the maximum uh, maximum PWM. So go down here, it's basically not going down. You can turn off the drone. So you can just turn off the drone. Then now our PWM is basically done. We know how much is the maximum and minimum. So it's just 1000 and 2000. It's just every drone may be differ, so I recommending you guys to do it yourself. So after you uploaded the code to the ESP32, then turn it on, go to the website and you will see this. So in this website, to put the minimum and maximum and connect the GPIO 2 and 4. You can go with 2 ESCs at a time. So you can there's a jumper wires. So actually one of my ESC got blown up, so make sure that buying cheap comes with risk. Now only one ground is needed, both the same color, and connected to the GPIO 2 and 4. So connected 2 now. Then the ground, and take one more jumper, connect it to the PWM signal. This is this one is the black one is the ground, then the voltage, then the PWM. You have to connect both wires, then you can just control it on the main board. So you have to connect the motors. Put the PWM at 100. So to calibrate it, you have to put it on the maximum value first. So for me it's 200, so I go 200, then connect the battery, then you'll hear the beep, then drop down to the lowest. There you go. Now you have the 1 2 3 5 6 7. So eventually it should run here. There we go. So build the frame, then calibrate the ESC. It will be much easier. Now I have recalibrated the ESC. Now it can now work. You can see right there, it's not working. So I think it's the final step is going to be correcting the orientation of the motor working. So there is a specific way the 4 motor should run on a drone. So according to the image shown in the display, you can correctly change it. So let's see for a second. So this motor need to go opposite direction. It's going like this. It should go like this side. So to do that, just remove 2 wires from the bottom. There will be 3 wires going for the motor, so just switch 2 wires. That's all you need to do. it. So now it's in the correct direction. Also doing for here, this motor, I have to switch it the same way. Take 2 wires, swap 2 wires, that's all they need to do. Okay, swapped it. You can see it's now, there we go, it's there on this one, correct way, this one, correct way. So it's basically done. So the next step is adding propellers. So to add propellers, you have to be in also in specific order. So guys, we have recalibrated, and I want to say that buying cheap ESC is a bad idea. I got 2 blown away ESC. Then not all ESC is going to have minimum PWMs. You can fly right now, just it will work, but if you want to get more control, better stability, you should go with optical flow sensor. The sensor was on the V28 4DRC V28, so I'll be attaching to the front. If you look closely, there is this side, you could attach it right like that. It's the front also. You see the camera should be right in this hole. Now on to the testing part of the drone. I think due to the high PID values, the drone is trying to stabilize but can't do stabilization because of the more weight. So the drone is basically not flying. It just goes to left or right side, try to stabilize itself. I think we have to decrease the size to 10" to 5". It's not a big failure as we were able to learn about it, but we will try again. And I broke ESC and propeller again.